That's perfect for Monday. I think these exponent problems might actually be harder than the actual lesson. Okay. And you could argue that for a lot of the exponent problems, but anyway, all right. So this is a multiplication problem. So I multiply 2 times 4 is 8. Okay, and then I have to remember that plane V is V to the 1. So I have to add that 1 to the 3. So that gives me V to the 4. And then U doesn't have anybody to add with. Okay, and then U needs the reciprocal. So I'm going to circle him. 8V to the 4th over U to the positive 1. I kind of circled that poorly. And then I'm just going to rewrite it over plane U. You don't have to do that part. You can leave it over U to the 1. I will never mark that wrong. It's just that I like to make it look fancy. Okay, next. 2U to the negative 3. This is another one where we have to remember that there's little ones on exponents on both of these things. And this is a power problem, which means we're going to multiply those exponents. So I have 2 to the negative 3 because negative 3 times 1 is negative 3. And U to the negative 3 because 1 times negative 3 is negative 3. Okay, do you see any that need reciprocals in this one? Yeah, both. So this is going to be 2 to the positive 3, U to the positive 3. What do we do when there's nothing on top? 1. Beautiful. Whoa, what happened to my fraction bar? Got wiggly. Okay. 1 over 8U to the 3rd. Are you sure? Never? I think never is kind of a strong word. I don't know. I think you might have. Okay. Luckily, if you look down the page there, we have more practice of this coming up. Today we are doing problems 11 through 16. There's a resource page and you need your notebook. So find the resource page. It's right after the tile pattern one we just did. It's got like triangles and graphs and whatnot. It says 2.1.2 resource page on the top. 2.1.2. And then also you're going to need your notebook or a piece of graph paper. None of these problems are difficult. I think the ones we just did were worse. Homework tonight is 18 through 22 in the CPM book. And there's Willy Wonka, and he said, so you were on Snapchat in math class? Please go on, tell me how to find the slope of a line. Guess what we're working on today? Math. Slope of a line. It is math, technically. Whenever I ask my son what he wants to have for dinner this week, he says food. Oh, so that same sort of answer. Yeah. Smart Alekin since 2001, that one. Miss Destiny, did you ever get to meet Carter or Archie? Either of my two kids? Before your time here. 2020 and 21. But COVID took out most of that. So that was really sad for us. That was sad for us because Okay, guys, so this is a problem that is exactly like number 3 from Fridays. So number 3 from Fridays looked like this. It asked us to have a table and find the equation. And so we're going to basically review that from Friday, which is great. I want to remind you of a couple of things. The equation is y equals growth x, growth times x. Put a little dot there. I put the dot because I'm doing a word times x, but usually it's just a number for the growth, plus figure 0. Okay, so how you find the equation is you put the growth in the first spot in front of x, and then how many tiles are in figure 0. Okay, so in this problem, what is the growth? 5. So I'm going to put a plus 5 here. So my equation will be y equals 5x plus figure 0. Figure 0 has 2 tiles. So the growth is how much it goes up by each time. And this is how many tiles are in figure 0. Okay, what I want you guys to do is find the resource page for number 11, the graph for number 11. We're going to graph these dots. But before we graph them, I want to tell you, do not connect them. Don't connect them. No connecto. Just graph the dots only. Okay. Zero, 2. Notice that this graph is going by 2, so we have to be careful. 0, 2, 1, 7, 2, 2, 12, 3, 17, 4, 22. I just graphed that in the wrong spot. That's not 22, that's 21. That's okay, because I live in a land of whiteout. I need to live in a land of whiteout. That is a need that I have. Also, really can't do white carpets or a white couch. No, not for Mrs. Talbot. Okay, resist the urge to connect the dots. We don't connect the dots when it's a tile pattern. Why? Because there's not a figure 1.5 or a figure 2.96. You could make one if you want to. Go ahead, make a figure 2.96. Don't do it. We don't have time. Okay, but we really want to. So we're going to write ourselves a note over here. Okay, now we're going to break the rules. I know it's crazy. Now I want you to connect the dots. Okay, because we're going to look at something else. So we don't do it unless you're specifically told to, in which I'm specifically telling you to right now. Do your best. There's straight edges at your table in the basket. It's fun to break the rules. Exhilarating. Okay, now my next question is for number 12, if we connected them now, is it a function? Yes, why? Mm-hmm. By the way, back on the test, it does not count to just draw a bunch of lines on there and expect me to know about it. If you did not say it passes the vertical line test, you got marked off. I can't remember who did that and who didn't, but I know some people just drew lines on there and expected me to interpret that as something. Okay, now this is the question of the day. This question is so easy, it's hard. What is the equation of the function that we just connected the dots for? Y equals 5x plus 2, except, yes, beautiful, f of x equals 5x plus 2. Because it's a function, we can put it in function notation, which is exactly the same thing. I want you guys to write this and put a box around it. That is super important. Every time that I put y, you can put f of x. Every time that I put f of x, you can put y. Those two things are the same thing all year, all next year, and the year after that, and the year after that, and calculus. They're the same thing. Did anyone get completely stuck when I asked them what the equation was of the function, thinking it was going to be something completely different? No? Okay. I just thought maybe we like forget that we just did an equation. Okay, all right, go ahead and draw number 13A. You guys have been with CPM for a while, most of you, some of you have not. Do you know what the multiple representations web is? Have you ever heard of the multiple representations web from CPM? Okay, that means, so there's this like flowchart dealio, and the top, I can't remember, but it's situation, graph, table, equation. So you should be able to go back and forth from a situation to a table to a situation. Actually, if you have Mr. Modavers, he makes you write situations for your tables all the time. You should be able to go from the graph to the table to the graph, equation to the table to the graph. Wait, no, I forgot the other thing. There's too many of them for me to list, but you should be able to go between all of them. So today, in this problem, we're going to go graph to table to equation. And the table is always a great spot to have a midway. could write a situation for this. Mrs. Talbot has 3 Squishmallows. Every day she buys 2 more Squishmallows. How many Squishmallows does Mrs. Talbot have? Many, many Squishmallows. Dial 911 because she might be trapped under a pile of Squishmallows. Less than or equal to the amount that I want to have. Anyway, I did not get 2 Squishmallows this weekend. Did not get any Squishmallows this week. Well, because I have to be a reasonable human being. And anyway, okay. Enough stalling so you can draw it. First, put an X and Y here. Notice I've switched from figure number and number of tiles to X and Y because I want to extend this to all situations, not ones that are just tile patterns, but it helps us get started. Can you guys tell how many tiles are in figure 0? 3. So figure 0 has 3 tiles. How many tiles are in figure 1? 5. And then we don't really need the picture anymore. We can tell with my Amazon arrow that the growth is 2. So figure 2 would have 7 and figure 3 would have 9. Any questions about going from the graph to the table? Okay, now we're going to go from the table to the equation, y equals, and I'm just going to remind you right now in the middle of the lecture. Okay, I'm getting close. Okay, so I'm going to remind you the equation is y equals growth x plus figure 0. So y equals growth x, yep, plus figure 0.
I love math.
It loves you. Okay, but did something click there? We got it. It's better. Yeah. Okay, I have one more for you to draw. Noise. And we don't have to draw anymore today. It makes you feel better. The book had a C and I decided to skip it because you'd be in AP art all day today. I think you'll get the point after this one. And then the rest of the problems are on the resource page. Luckily, we don't have to draw them and they'll be much quicker. All right, here we go. X, Y. Figure 0 is here. So this is a more abstract drawing, but it's okay. We can still tell how many tiles are in figure 0, 9. And then this is called a sloped triangle. It's telling you that for every figure number you go up, the number of tiles goes up 12. For every figure number you go up, the number of tiles goes up 12. So 1, 2, 3. So I'll go up figure numbers
This is gonna go up by 12, so 21 plus 12 is 33 plus 12 is 45. Okay, now last bit, y equals growth x plus figure 0. Okay, you guys are done with notebooks. Go back to the resource page. Same one we were just working on. And we're just going to focus on growth for these last three. Okay, here's the first one. This one, we can't really tell how many tiles are in figure 0, but that's not what it's asking. We're just looking for growth in this problem. And this problem is telling us that it's going up 27 tiles every 3 figures. It's telling us that it's going up 27 tiles every 3 figures. So what is the growth for each figure? 9 tiles per figure. Okay, now we're going to change the wording up a little bit in number 15. That's it for 14, by the way. Best problem ever. I know. Okay, now number 15, we're going to change up the wording. Instead of saying growth, we're going to change it to slope. What do you know about that word? Okay, and we're going to call it M. I don't know why they call it M. Something to do with an M in it. Okay, but M has a couple of different ways to remember it. Some people remember it with rise over run. Some people remember it with change in Y over change in X. So this symbol, this triangle is the word delta. It's a Greek letter delta, and it means change. Nice, good. So that means height over base, height over base. Okay, so we're gonna do this. We're gonna use this for number 16. We're gonna do 3 little baby problems. The slope of triangle A. Slope of triangle A. So rise over run. 6 over 4. And then we're going to reduce that to 3 over 2. Slope should always be reduced fractions. What's the slope of triangle B? Yeah, you feel like you're doing something wrong. It's just 3 over 2. Rise over, that's it. Technically, doesn't it make sense that they would all have to be the same thing? Okay, now the last one is a puzzle. What would the top have to be in order to reduce with the 3 and get 3 over 2? Okay, you can kind of cheat by looking at this. How long is this? 4-ish. 4 what-ish? Yes. And if you divide both of these by 1.5, you still get 3/2. Okay, the moral of the story here is it doesn't matter where you draw your slope triangle, you're going to get the same answer anytime. So you could draw it anywhere you like. I certainly wouldn't suggest drawing it in the middle of a half square like I did on this last one, but just saying, you'll get the same answer either time. Okay. That is it for me, but hold on. Landon, bathroom, then give the thing to Lily, okay? All right.